Why building a nuclear bomb is so simple? Why doesn't everyone have one?
A sphere of plutonium the size of a grapefruit holds enough energy to erase Manhattan from existence. While we've all seen mushroom clouds in movies, most people don't know the science behind nuclear bombs. The word atom comes from the Greek word for indivisible, but it turns out the Greeks were spectacularly wrong. Atoms can be split apart or smashed together, and when they release energy that makes TNT look like a tiny firecracker. Einstein's famous equation, E=mc², shows that even a tiny amount of matter contains staggering amounts of energy. For example, just 1 gram of matter, if completely converted to energy, equals the explosive power of 20,000 tons of TNT. Nuclear fission is the process of splitting atoms. When a neutron strikes an unstable nucleus of uranium-235 or plutonium-239, the nucleus splits, releasing a massive amount of energy and 2 or 3 more neutrons. These neutrons fly off and hit other nuclei, creating an exponentially accelerating chain reaction, which is the beating heart of every nuclear weapon. You can't just grab any uranium to make a bomb. You need a critical mass, enough fissile material packed tightly so that the neutrons are more likely to hit another nucleus than escape. Fission is about breaking atoms apart, while fusion is about forcing them together. Fusion, which powers the sun, involves slamming hydrogen isotopes together to form helium, releasing even more energy per gram than fission. Because recreating the sun's extreme conditions on Earth is challenging, fusion bombs or hydrogen bombs are two-stage devices. The first stage is a fission bomb that provides the extreme heat and pressure needed to ignite the fusion fuel. Building a nuclear weapon is a complex engineering challenge. The designers had 2 basic approaches: the gun type and the implosion type designs. The gun type, used in the Hiroshima bomb Little Boy, was simple but inefficient. The implosion type, used in the Nagasaki bomb Fat Man, was more elegant and is the template for most modern weapons. Fat Man was a masterpiece of precision engineering, using explosive lenses, carefully shaped charges of conventional explosives arranged to create a perfectly spherical shockwave. This shockwave compressed a subcritical plutonium core into a supercritical state in a fraction of a second. The timing had to be perfect, with 32 separate charges detonating within 1 microsecond. Even with perfect compression, you need a neutron source to start the chain reaction at the right moment. Fat Man used a device called a neutron initiator, which produced a burst of neutrons at the moment of peak compression. Once the chain reaction started, it doubled every 10 nanoseconds, releasing the equivalent energy of 21,000 tons of TNT. The immediate effects of a nuclear detonation are horrific. The initial fireball reaches temperatures hotter than the sun's core, releasing a thermal pulse that can cause severe burns miles away and instantly vaporize objects. This is followed by a blast wave of compressed air traveling at supersonic speeds, which destroys buildings and creates powerful, lethal winds. Finally, there is the initial nuclear radiation, an invisible killer that can deliver lethal doses to people far from the blast. These immediate effects are compounded by the long-term danger of radioactive fallout, which can spread for hundreds of miles and contaminate land and water for centuries.